this will be lab class number 7, and in this lab class we will be demonstrating the DC motors as an actuators. So, actually we will be showing it to you how DC motor can be used as an actuator, right. It is a small demonstration. So, focus on that particular laboratory experiment, and if you have any question feel free to ask. Lab 7 will be demonstrated, this will be Arjun will be teaching you the demonstration of this DC motor as an actuators, and if you like I said, just look at it, this is just one example. Okay. Instead of DC motor you can use some other actuators as well. Okay. But just to help you out how can you use DC motor as an actuator, we are taking this particular experiment in this particular course, and then let me discuss more about lab class 8 in a coming module. So, lab class 8 will be more on the peristatic pump using Arduino. So, I will be talking about the lab class just before we demonstrate you how you can connect the peristatic pump with Arduino board. Till then you take care, have fun, enjoy lab classes, right, and I will see you in the next lab class. Bye.
Hello and welcome to the Sensors and Actuators course. In today's session we will be discussing about some of the actuators that we have discussed in the previous lectures. So, you must have heard what sensors are, what actuators are, okay, and even the working principles of sensors as well as actuators. Today we will see some demonstration of different actuators, and first I will be showing you the demonstration of a DC motor. Okay. So, you have seen how a DC motor works and how its internal wiring is and how it works, what is the principle of operation of a DC motor. So, I am going to show you how to use DC motor as an actuator. Okay. So, the DC motor, as you know, will have two terminals across which you can apply a potential and the motor will start rotating. If you reverse the direction of the potential, the motor will rotate in the opposite direction, right. This is what you must have discussed or learned in the previous lectures. So, as long this is a simple process that we have discussed now, but when it comes to a mechatronic system or a robotic system, you need to control it by some intelligent means. You cannot just switch the motor by its just switching the polarity of the battery, but for this process, instead of manually changing the polarity, you will have to use some other intelligent means. So, in the previous lecture we have or previous session we have discussed how to use an Arduino board and how to interface an Arduino board with a potentiometer, LED and other things. So, and different functions of the Arduino. So, here we will be using that Arduino board to control the direction of and speed of the DC motor. So, this will be an experience to you because you will see how in an industry, not exactly in an industry, but how it logically works using an external circuit and in programming to control the direction as well as speed of the DC motor. After this session we will be discussing about different pumps and so on in the coming lectures. Okay. Hi. So, here you can see a circuit, right. So, yeah, this is the DC motor. Okay, this is one of the examples of a DC motor. We usually call it DC geared motor. Other than that, there are Johnson's motor, BO motor. So, different type of motor are there. Industrial grade motors are different, and you can see some other things. Okay, this board you are familiar. This is a Arduino Mega board. I have previously shown you this, and here we have something different. What is this? This is a motor driver board. Okay, this is a motor driver, or its name is L298N. Okay. So, I will be showing you how it works, and here we have a DC power supply. I have used this instead of a battery. You can see the current drawn and the voltage over here. It is 11.8 volt, but the motor is not rotating. I will show you exactly how. Okay. So, here you can see some components on my screen. Okay, this is a PC, an icon of a PC. This is a trimmer or a potentiometer. You have seen this in the previous session. This is the Arduino Mega board that also we discussed previously. This one might be new to you, but you must have seen this also in the session, a motor driver circuit. This is a L298N, and I have kept a battery here instead of a DC power supply to make it easy for you to understand. And here we have a DC motor. I am just going to tell you how we wire this and how it works and how is the logic behind it. Okay. So, this is the main thing that is unknown to you. So, I will just introduce it fast to you. Okay. So, this is a L29810 motor driver. Okay. So, you can see some markings here. Why do we need to use a motor driver? Okay. So, in the previous session I must have told you that the Arduino Mega can give 5-volt output, right. So, if you write digital write high or something, we have seen in the previous sessions that Arduino Mega can give logical outputs. So, logical output means it can give either 0 volt or 5 volt as the output, or even the analog values, not exactly analog values, but by means of a varying voltage by means of PWM. Okay. So, how does that one actually be used in case of a motor? How that signals can be used in case of a motor? So, the motors actually work with high voltage as well as high current, but you can see that the Arduino can only provide 5 volt as well as current maximum up to around 200 milliamp. That is 200 milliamp is the rating of the Arduino. So, the current output of the Arduino will be as low as even 40 milliampere. So, this current will not be sufficient enough to rotate, make the motor rotate. Some motors take even more than 1 or 2 amperes. So, with this 20 milliampere or 40 milliamperes of such small current from Arduino Mega, we cannot make the motor rotate at the required speed and required torque. So, that is why we use a motor driver. You can see here is a motor driver. So, what we do is, this is something like a logical circuit only. What happens is, when you give the signal from Arduino, where you can see here, when you give signal from the Arduino somehow, it will go to the motor driver. Motor driver will make some decision based on that, and from an external power source, it will divert power to the motor. Okay. So, this Arduino Uno over here may be providing only 5 volt, but some logical signals to the motor driver, and based on this logical signals, it will divert power from this 9 volt battery, which can also deliver some high current to these motors. So, this is how it works. So, you can see here there is a input for 12 volt, that is where you connect the 12 volt or the positive terminal of the battery to this board, and also this is the ground where you ground pin where you connect the ground of the Arduino as well as the battery. Why we have to connect both ground of Arduino as well as battery is that because we can ground the or common ground the Arduino as well as power supply. We need to do that so that the reference will remain the same. So, you have to common ground both Arduino as well as power supply over here. Then you have a power 5 volt input. This is for powering or making the IC over here work. So, the IC here works at 5 volt logic, and you need to give some 5 volt supply for it to work. Usually what happens is there is a regulator within the circuit, so that even if you give 12 volt power supply, it will convert or using a voltage regulator, it will create 5 volt and make this IC run. But you can also give this one. So, you can see a onboard 5 volt jumper. So, if you remove it, you have to give an external power supply, otherwise it will directly give 5 volt to this one, but you have provisions for both. Then you can see 4 pins over here, 4 jumper pins or male pins over here. So, this is where you can give input signal to this board. Okay. So, these are the 4 pins where you give input signals to this board. So, you can see an output A here and output B and 2 terminals from each, right. So, a L298N board can give control 2 motors. So, a motor requires 2 terminals and to control it, 1 positive terminal and 1 negative terminal. If you switch the potential, it will rotate in the opposite directions, right. So, you need 2 terminals for the motor. So, one of the 2 terminals for if I have a motor here, these two terminals can drive one motor, and another motor over here, these two terminals can drive it. So there are 4 terminals for output, and similarly we have 4 input terminals. So these two, one over here and one over here, you can see the in 1 and in 2 are for a motor over here, and in 3 and in 4 are for motor over here. So this is how we give the input. So a logical input, that is if Arduino makes this sends a high 5 volt signal to in 1 and a ground signal or a low signal to in 2, then this pin will become 12 volt, because if we are connecting 12 volt power supply here, this pin will become 12 volt and this pin will give ground. So the motor will start rotating in one direction, and similarly if you make this in 1 low and in 2 high, similarly this one will go high and this one will go low, and the motor will rotate in the opposite direction. Similarly we can use in 3, in 4 and take output from output 3 and output 4. This is how a L298N works. So you know how important this circuit is when it comes to rotating a motor. Similarly, most of the motors as well as actuators will have a driver circuit like this to control it, because the microcontroller or the microprocessor can only give some digital or logical signal. So this logical signal will have low voltage as well as low current, which is insufficient to make the actuator work. Okay. So I will show you how I am going to wire this one. Okay, so you can see a PC to which my Arduino Mega will be connected. I have a trimmer here, I will use it later on. So here we have the L298N battery and the motor. Okay, so I will be using this output here, and I will show you how I am going to connect it simply. Okay, so first I am going to just connect my PC to the COM port of the Arduino Mega. Okay, so we can use the Arduino IDE on my PC and send data as well as write data or change the program or whatever we need to do with it. Okay, now as I said earlier, we have to connect the 12 volt, okay, 12 volt of the battery to the 12 volt terminal of the L298N. So I have connected it. So now I can connect the ground also to the battery. So the L298N will get 12 volt as well as ground. And I also said that we need to make the common ground from the Arduino. So this is the ground over here in Arduino. So I am just connecting it. Okay. So now I have made the ground common. Okay. I can also give the 5 volt if I wish. Since the jumper is here, this jumper is over here, we need not actually give power supply to this one, but still for your better understanding I am giving this 5 volt. Over here. So this IC will be powered up now. Okay, this IC will be powered up now. Okay, so this is how you connect the power supply to the system. Okay, now I am just wiring the output terminal to this motor as well as this output terminal to this motor, from the motor driver to the motor. Now we have to give the input. Okay, we have to give the input. So I am going to take the pin numbers 2 and 3 from the Arduino to these ones. So I am just taking a different color here. Okay, you cannot see maybe. Yeah, I will connect it like this, and another one just like this. So we have connected the connection over here. Okay, you can see that. Now if I upload the code to the motor that I will be showing later on, it will start, the motor will be start rotating based on the signal that is sent from the Mega. This is how the connection goes. So this is a better connection of something like that. But we have a Mega here. Okay, and the pins are different. You remember this Arduino IDE I showed you before, right? So I am showing a simple code over here. Okay, you remember void setup. Now pin mode 2 comma output, that means the pin number 2 of the Arduino Mega is output. Then pin mode 3 comma output, that is the output pin 3 is also output. The digital pin 3 is also output. Then inside the void loop I have only written two statements. One is digital write 2 comma high and digital write 3 comma low. So as I already explained in the picture before, that the pin number 2 and 3 are connected to the input pins of the motor driver. What happens is, if I say that 2 is high and 3 is low, that means the motor will get 12 volt in one of the pins over here. The motor will start get 12 volts over here and ground over here. That is what this symbol code means. Okay, this is what the symbol code means. So we will see how this code works. So I am just going to upload this code into the Arduino board now by pressing this button. So when I press this upload button, the code is being uploaded and you can see the motor rotating, right? Yeah, so the motor is rotating now. So this is a 1000 RPM DC motor and you can see that it is rotating. I can change the code now. So I am going to just change the code now. So if I make this one low and upload the code, what happens? See, the motor stopped. So you can see that the motor has stopped now. So this is because both second pin as well as third pin are low, or both are similar to ground or 0 volt. So the motor driver will not give any more 12 volt supply to the motor and motor is not rotating. If I change this one, the third pin to high and upload the code, then the motor will start rotating in the opposite direction now. Okay, so this is how this logic from an Arduino is translated to a rotation of motion by means of a motor driver. Okay, so we can do different functions here. So you remember the delay functions, right? So if I am doing a delay function here, say for 5000 means 5 seconds, you must be remembering. Okay, so what happens if I run this code now? The motor will be rotating in one direction for 5 seconds. After that it will be off again, and for 5 seconds it will be off. Then again it will start rotating. So I am uploading the code now. See, I have uploaded the code. So the motor starts rotating. It will rotate for 5 seconds. Okay, it stopped. It will remain not rotating for 5 seconds. Then again it starts rotating. So this is how you program a actuator by means of Arduino or any other programming board. So it can be Arduino, it can be Raspberry Pi, it can be MyRayo. So it can be any other programming board, any other microcontroller or processor. This is the logic how everything works. Okay. You remember the circuit that we drew before, right? And now we are going to use this trimmer. So what happened previously was, when we used the Arduino and the motor together, you can see that the motor was running at full speed in one direction. We made it off, we reversed the direction, then we ran it intermittently, right? So now I am going to show you how to control the speed of motor using a potentiometer. So if we connect a potentiometer in series with a motor, you know, it's a simple circuit that we can use. So we are going to use some logical operations here now. Okay. So I am going, as you know, the wiring of the potentiometer, like what we discussed in the previous class, I am just connecting the potentiometer to the 5 volt now, and similarly the ground also. Okay. Then we have the signal pin. I am just taking the color blue and I am connecting this one to analog pin A0 of the Mega. So this is the circuit, I have just connected it. I will take you to the code. You remember this code like before also. pin mode 2 comma output, pin mode 3 comma output. So the pin numbers 2 and 3 are output. And then I have defined analog pin A0 to be input. I have told you before, even if we don't do this, it's okay. By default in Arduino, analog pin A0 is input only. And in the void loop, like how we use the same thing, the dimming of LED or changing the brightness of LED with the help of potentiometer. Here I have done the same operation. I have put index equal to analog read A0. So the value from A0 is read and put it in stored in the variable integer variable x. And in another operation, I have made the or created the variable integer variable y and stored it with the value x by 4, because you remember that the analog value when we read it is in the range of 0 to 1023, and the PWM output that we usually give was in the range of 0 to 255, and this is by 4 operation approximately. So then I have given analog write 2 comma y. So this function also you must be remembering, this is a PWM output signal. Okay, if we used digital write, this is invalid, it can only be high or low. So if I am using analog write, the value should be given in the range of 0 to 255. So that is what going to happen here. And I have only used digital write 3 comma low here, because the motor, the third pin will be connected to the motor driver, and it goes to the motor also and is grounded. So we need not give any special PWM signal there to control the speed. So this is how it is connected. The circuit remains the same, just that I am taking the value from the potentiometer, dividing it by 4. That value is being written as PWM to the second pin of the Arduino board. This signal, this PWM signal will go to the motor driver, and the motor driver will change the speed accordingly. Okay, so I am uploading this code now. I am switching on the power supply now, but you can see the motor is not rotating. Okay, so I am going to turn the potentiometer, slowly increase. You can see that the motor starts rotating and its speed is increasing. See, you can adjust the speed of the motor now, correct? I am again reducing the speed. So this is how you control the speed of the motor. Okay, even I can show you the variation in both motor speed with respect to potentiometer as well as on the serial plotter also. So I have updated the code now. I have added the serial begin function to transfer the data from, or serially transmit data from Mega to the Arduino IDE to the in the PC. In the void loop, I have did the same thing and added this one to adjust for the scaling defect in Arduino IDE plotter. Okay, you remember that one, right? It's not necessary actually, but I am doing this because you will get a idea by seeing a constant scale. It's the same thing everywhere. I'm just uploading the code now. Okay, I'm just taking the serial plotter. So you can see that the potentiometer value is somewhere down here, the green line. The green line is the potentiometer value. Okay, I'm just increasing the port value now. You can see that the motor starts rotating. At the same time, in the serial plotter also you can see that the value from the analog value from the potentiometer is being increased, right? And when we reach the maximum value, the motor will be rotating at its rated RPM, that is around 1000 RPM. See, now the motor is running at 1000 RPM. If I am decreasing it again, motor speed will start reducing. You can hear that sound variation also, right? Apart from seeing the motor shaft rotating. Yeah, so this is how it works. Okay. So we have seen how we make a motor rotate, a DC motor rotate with the help of Arduino. So any mechatronic system or any robotic system will be having a microcontroller or a microprocessor to control the actuator, and there will be some driver circuit, there will be power supply, everything in between. So this is how we use an actuator. Okay. In coming sessions we will be discussing about different pumps, other type of motors and other things. So thank you.